Hello everyone, I am Dr.J.R.Deepak, Associate Professor, Department of Mechatronics, School of Mechanical Engineering, Sathyabama Institute of Science and Technology. In this session, we will be looking into a topic, robotics. The subtopics which we will be covering are introduction to robots, types of robots, applications of robots, and few terminologies that are being used in robots. To start with, what is a robot? A robot is a reprogrammable, multifunctional manipulator designed to move materials, parts, tools or special devices through variable programmed motions for performing a variety of tasks. In simple words, you can say a robot is an electromechanical device. Basically, robots are being used in a variety of applications in industries. Let's quickly go into the applications of robot. The applications of robot can be categorized into four categories. One is material handling application, process application in industries, assembly and inspection applications. So when it comes to material handling, most of the robots are being used for pick and place operations in various industries. To transfer material from one place to the other, robots are being used. A very important aspect called as palletization. When identical objects are to be transferred from one place to the other, a tray or a pallet is being used in which robots will identically arrange all the items on the pallet and the entire tray will be lifted and it will be moved to the other place. This kind of a transfer is called as palletization. Robots are also being used for machine loading and unloading application. Machines can be loaded with raw materials and the finished components can be removed and it can be stored in the packing area. It is also being used in various process applications like welding. If in case of welding application, robots can be used for spot welding, laser welding, TIG welding, MIG welding, arc welding, and it is also being used for spray coating, painting and other applications. It is also being used for laser cutting, water jet cutting, for grinding applications. Robots are being used. Robots are also being used in the assembly lines to assemble parts, as well as robots are also being used to inspect the components. Robots are also being used to check the quality of the product. A very important aspect of a robot is work volume of a robot. A work volume of a robot is the space within which the robot can manipulate its end effector. The word end effector is the last portion of a robot which can easily access the part. So if you take up an example of this robot, there is a gray area which is the work volume of a robot. This gray area is said to be the work volume. The space within which the robot can very easily operate, or it can pick objects, it can move, it is being pivoted. So this operation area is said to be the work volume of a robot. There are four types of robots which are classified based on the configuration. One is polar configuration robot, Cartesian coordinate configuration robot, cylindrical configuration robot and jointed arm robot. A polar configuration robot is being classified based on the movement and the links and joints that are being used to build this robot. It consists of a sliding arm which has a L joint, a linear joint, which actuates and it tries to bring out a linear movement. Example, if the robot needs to have a retraceable arm, it needs to have a linear link and a joint. So here, in case of polar coordinate robot, the base is being pivoted at a particular point and it has a retraceable arm which can move to and fro, and you will also be able to rotate. The base can be revolved all 360 degrees, and hence what kind of a work volume this polar configuration robot will bring is the work volume is a partial spherical shape. When it comes to a Cartesian coordinate configuration robot, all the links and joints which are being used in Cartesian coordinate robot, linear joints. Every joint has a linear movement, and thereby the work volume of a Cartesian coordinate robot is a rectangular box shape. A cylindrical body configuration robot is pivoted at the center, and the robot will be able to access its end effector all 360 degrees pivoted at the center. It will be able to move up and down on the axis. It consists of a vertical column where the manipulator can move up and down, and it will also have a retraceable arm where the end effector can move freely inward and outward. So, the work volume of a cylindrical configuration robot is a hollow cylindrical shape. A jointed arm configuration robot is a type of a robot where it will have 2 rotation joints and 1 twisting joint, where the base is being pivoted and it will be able to rotate not 360 degrees, but it will be able to rotate 270 degrees. Hence, all the rotation joints will be able to bring out a free movement to the end effector, and when it rotates a 270 degrees, the work volume of a jointed arm robot is a horseshoe shape, which is irregular in nature. Robot anatomy. The important parts of a robot are: it starts with the base, it has links and joints, the body, arm, link and the end effector put together is said to be a manipulator. At the end of the link, you will have an end effector which is being used for a particular application. So, it has an arm, it has a manipulator, it has an end effector. End effector is the last component of a robot which actually makes a direct contact with the object. If in case of a pick and place robot, the arm or the gripper is said to be the end effector. There is a driving mechanism which tries to power and drive the robot, and there are controllers which tries to bring out a controlled motion to the robot. The wrist assembly is a very important part where you will have 3 types of motion, which is wrist roll, wrist yaw and wrist pitch. The wrist pitch is the top and bottom movement of a particular arm. A top and bottom, when you try to move your arm to top and bottom, that is said to be wrist pitch of a robot. When you try to move your arm to the right and left, it is said to be wrist yaw. And when the robot wrist is being revolved on its axis, it is said to be robot roll. Let us quickly go into the various end effectors that are being used in the robot. There are a lot of end effectors which are being used in industries for unique industrial applications. Let me classify the end effectors. It is being classified into 2 broader categories. One is tools, another one is grippers. Tools that are being used as an end effector are for welding application. There are welding guns, spot welding guns. Painting applications, there are spray painting guns which are being used as a tool, a drill bit which can be used as a tool for an end effector, grinding, for deburring, any manufacturing operations you can use a tool for the robot. Even a water jet, a torch or a cutting torch or a heating torch can also be used as a tool in case of a end effector. In case of a gripper, grippers can be classified into mechanical gripper which are being actuated by links and joints, vacuum cup grippers which actually works with the vacuum cup, and magnetic grippers basically working with the magnetic source where you have permanent magnets, you have temporary magnets, and you have adhesives which are being used as a gripper, and simple hooks and scoops are also being used. Basically there are few links and joints which are being used in robots are linear joint, rotation joint, revolving joint and twisting joint. Linear joints are said to be translatory joints or which brings out to and fro motion. When it comes to rotary motions, it is called as a R-type joint where link 1 is being fixed and the second link is going to be pivoted which can be rotated. A revolving joint which revolves around its axis where link 1 will be fixed and link 2, the output link, will be revolving. And the fourth type of a joint is said to be a twisting joint where the link 1, which is the input link, is rotating, as well as the output link, which is kept 90 degrees, which will try to revolve around the input link. The drive systems of a robot is basically categorized into 3 categories. One is hydraulic drive system, pneumatic drive system, and electric drive system. Hydraulic drive systems and pneumatic drive systems are being classified based on the type of the fluid that is being used. If in case of fluid medium, a liquid medium, then it is said to be a hydraulic drive system. If in case of air or a gaseous medium, it is said to be a pneumatic drive system. Basically, hydraulic drive systems are being used for higher load carrying capacity. It requires a larger floor space, and piston cylinders and rotary vane actuators are being used in order to bring out the motion. If you want to bring out a linear motion, a piston rod arrangement is being used, both in case of a hydraulic drive system and a pneumatic system. If in case of a rotary motion, then a rotary vane actuator is being used. The only difference is the fluid medium. If it is going to be a hydraulic fluid, then it is a hydraulic drive system. If it is a air, then it is a pneumatic drive system. When it comes to an electric driven system, DC, servo motors, stepper motors are being used, where the speed of action is very faster. The electric driven motors are very quick in response, and that can be very easily actuated. It can be controlled in a very easy way, and the preference which can be given among all these 3 are electric driven robots, because these are highly accurate in nature, highly repetitive in nature, and it can have a quick speed of response. Let's learn about the few terminologies in robotics. Precision of movement of a robot. When do we say a robot is precise? Here are few terminologies which you need to know, which is spatial resolution, accuracy, repeatability, load carrying capacity, and speed of movement. Spatial resolution. The smallest increment in which a robot can divide its work volume is said to be spatial resolution. When the robot is being able to achieve its possible point 1 and point 2, and when you are able to move it freely from point 1 to point 2, the space within which you are able to move is said to be spatial resolution. Let me give an example. AutoCAD is a software where you have an option called as grid. When you switch on grid and when you try to create a drawing on AutoCAD, the cursor moves through the grid points. If the grid point spacing is more, the cursor will try to move in a rectangular step fashion. When you try to bring out the grid points spacing closer, you will have a smooth curve that can be formed on a CAD software. Same is the case for a spatial resolution. If the space or the working space of a robot can be divided into small number of increments, then the robot can be highly precise or highly accurate in nature. When do you say a robot is highly accurate in nature? Accuracy is the capability or trying to position the end effector on a target point which is right in between a spatial resolution or the desired points. You have a possible point 1, you have an adjacent point 2, and you have a target point somewhere in between, and if you are able to achieve the target point by bringing out your end effector and stopping on the target point, then you can say your robot is highly accurate in nature. So this reaching out the target point somewhere in between will make your robot even more precise. Repeatability is the ability of the robot to position it back to a point that was previously being taught. Robots are highly repetitive in nature, and robots can be taught certain points, and that can be brought out again and again to perform a particular repetitive operation. The ability of the robot to position back to its original point, which is being taught previously, is said to be repetitive. When you compare the drive systems of a robot, electric driven systems are highly repetitive in nature. Load carrying capacity is the ability of the robot to lift whatever load that is being given. When you compare the drive systems of a robot, hydraulic drive systems has higher load carrying capacity when compared to pneumatic and electric driven system. Speed of response or speed of movement, the speed within which the robot can manipulate its end effector and accelerate from one point to the other point, that is said to be speed of movement. When it comes to electric driven robots, robots are highly quick in response, and you can say electrical driven robots are highly faster in response. The speed within which the robot can manipulate its end effector by giving a quicker response will also makes the robot highly precise in nature. When we compare all the three types of driving robots, one is hydraulic drive systems, pneumatic drive systems and electric driven systems. Hydraulic drive systems are stronger, larger, it requires larger floor space. If you take up a hydraulic system, it can be used for higher load carrying capacity. For heavier loads, hydraulic drive systems can be used, but the negativity is leakage of oil is a bigger nuisance. As well as it is larger, it requires a larger floor space. When it comes to a pneumatic drive systems, it can be used for handling smaller components, for lightweight applications. Whenever you need a quick response, you can go for a pneumatic drive systems, and it is very easy to maintain a pneumatic drive system. When it comes to a electric driven system, electric driven systems has a positivity of highly repetitive in nature, speed of response, very faster in response, and maintenance cost is pretty low, and it requires very low floor space as it is smaller in size. Position representation of a robot. The position of the end effector on a working volume can be defined by two ways. One is world coordinate system and joint coordinate system. When you try to define a particular point, in case the yellow mark where you can see there is a 3-link 3-degree freedom robot, where you have a end effector, the yellow mark on the link 3, where this is link 1, link 2, link 3 and the end effector. If you are able to position the end effector on a particular point from origin O, then you can say that type of a position representation as world coordinate system. When it comes to a joint coordinate system, every link and every joint is going to be calculated. The alignment of the axis of every link and joint, link 1, link 2, link 3, every length of the link and every angle that is being made has to be calculated, and the alignment of the axis has to be calculated to define the joint space. So, if in case of a joint coordinate system, you will be defining it by means of angles that is being made by every link and joint. So, when you want to define a particular point on the working space of a robot, you can define it by means of world coordinate system, that is x, y, z, if in case of a 3-link 3-degree freedom robot. If in case of a jointed coordinate system, you will be able to define the particular point by means of theta x, theta y and theta z. So, these are the two systems by which you will be able to represent a particular point on the working space of the robot. Thank you.